Welcome back to the Climate Solutions News. I'm Dominic Shales, and today we're talking about the food system broadly, and that accounts for roughly a third of global greenhouse gas emissions, and conventional protein production is responsible for a lot of that. It demands vast quantities of land, water, and chemical inputs. But what if protein could be grown from carbon dioxide and sunlight alone on land too degraded for agricultural purposes? Well, that's the proposition of Arborea, a London-based climate technology startup that's spent a decade developing its BioSolar Leaf technology. That's a modular system that industrialises photosynthesis to cultivate microalgae at commercial scale. And my guest today is Dr Kaly Chatakondu, Arborea's Global Commercial Director. He brings more than 30 years of senior food industry experience and a chemistry doctorate from the University of Oxford. Welcome to the podcast, Kaly.
Thank you very much, Dominic.
To kick things off, I mean, as I mentioned, you spent 30 years in some of the world's biggest food companies before joining Arborea. I think it was early last year, wasn't it? What made you confident enough to make that move, and what attracted you to Arborea?
Yes, good question. Because obviously throughout my career, I've often had startups approach me, and I was fascinated by the science, but equally compelling in the case of Arborea is the economic scalability, and that's often where startups come unstuck, in that they can't commercially scale up their technology. Inherently, this technology is scalable and is commercial, and it's super versatile. So it was enough to make me take the plunge and leave the multinational world and join the startup world.
How have you found it so far?
Intense, and I could say that it's probably some of the times that I've worked the hardest in my life, but also the times that I've enjoyed the most. It's like going back to university, with a really difficult degree course, but it is fantastic. I mean, obviously we're a startup where everyone does everything. It's 24/7, but the company is fantastic. I mean, it's 30 people, 13 different nationalities within that company, and we're sort of driven by that same vision. And that's what sort of binds everything together. This is a technology that could change things in the world. So, and that's what's driving us together. Yeah.
Very good. And for those people listening who haven't come across the BioSolar Leaf technology before, what is it? How does it work? How does it actually generate results?
Sure. So if you the human lungs, if you imagine ourselves, what do? We breathe in oxygen and breathe out carbon dioxide. The BioSolar Leaf does this in reverse. It breathes in carbon dioxide and breathes out oxygen inside breathing cultivation tubes. In those tubes, water is flowing, and in that water, microalgae is growing. So this is simply photosynthesis, a natural process that originated on Earth 3 billion years ago, but it's photosynthesis on steroids, if you like. This is industrial photosynthesis. The tubes can breathe in carbon dioxide and breathe out oxygen at just the right pace that you can harvest and cultivate that's microalgae every single day. And that's why it's so efficient as a food production process. You're getting 365 harvests a year rather than one or two. And you can do it on barren, non-fertile land in unlimited quantities.
And do you need a certain amount of heat or sunlight to be able to for the process to work?
Now, one of the beauties of the process is that it operates with natural sunlight, just like photosynthesis does in nature. You don't need significant quantities of heat at all. You do get twice the yield in summer than you do in winter. The more sunlight you have, then the higher the yield. But it will work as long as you have. I mean, if you can imagine, photosynthesis occurs all over the planet, no matter how much sun is there. It just happens a lot more when there's more sun. And it's the same with us.
And you're operational at the moment in Portugal, is that right?
That's right. We've got a pilot facility operating in Lisbon, Portugal. It is deliberately built as a one-to-one techno-economic facility that mimics exactly what a large-scale facility would be. And then now we're building our first full-scale factory, which will also be in Portugal, and that will be operational in the middle of next year, making several hundred tons of product.
Great. So we'll come on to talk about the commercial scaling a little bit more in a second. But first of all, let's just look at the process and the environmental kind of benefits of the process. I think you say that it is carbon negative as a process. How's that calculated, and has that been independently verified?
It hasn't been officially independently verified yet because the process needs to have a certain level of construction before that can be happen. But we have all the data that would informally, if you like, verify that. 2 tons of carbon dioxide turns into 1 ton of ingredients. And basically, you have multiple benefits in terms of the environment. You're obviously using carbon dioxide as a feedstock, as a free feedstock. It doesn't have to be pressurized. It doesn't have to be concentrated. This process works at a concentration below 2% of carbon dioxide. So literally it can come from anywhere. It can be emitted directly from a factory. It can be from burning agricultural waste. It doesn't matter. So that's a huge advantage there. It's on non-fertile land, so there's zero deforestation, zero loss of biodiversity. And in these tubes where the microalgae is growing, it's the same water that's recirculated. Every time you harvest, you recirculate the same water, so it's minimum water as well. So you have literally every box ticked in terms of environmental footprint, and carbon dioxide, as opposed to being a problem, suddenly becomes your feedstock.
Great, thank you. And in terms of the product that actually comes out, I think you're focusing on spirulina, which is a well-known sort of food additive. Just are there others as well? And what kinds of algae are you growing to give these different outputs?
Absolutely. We started with spirulina simply because it's so rich in protein. I mean, spirulina is around 65 to 70% protein. You also have a whole range of bioactive vitamins and minerals, iron, zinc, magnesium, B1, B2, and you have omega-3 fatty acids. So it's a great microalgae to start with. And then what we do is we would harvest the spirulina, which can be sold in supplements, smoothies, etc. But we can also extract the protein from it to make plant-based milk and other things. And this is a neutral tasting, neutral colored multifunctional protein. We can extract natural colors. We can extract bioactive vitamins and minerals. But to answer your question, this is just the first microalgae. This process can literally make any photosynthetic microalgae, of which there's over 30,000. You may want one that's rich in omega-3 fatty acids, one rich in other lipids for biofuels. You may want one that's rich in certain ingredients for pharma applications. This is industrial photosynthesis. It really doesn't care which microalgae you grow in these tubes. It's ultra versatile as a process. Well, we're a startup, so we had to start somewhere. We had to start with one, and we chose spirulina to begin with.
And in terms of the end customer base, are they? You're obviously marketing spirulina to big food companies, I imagine. Are they also coming to you at this stage to ask for particular types of proteins or products?
Absolutely. So we've got collaborations, joint development agreements, and offtake agreements with some of the largest multinationals in the world. Now, some are for the spirulina because it's a unique form of spirulina where you've controlled both the taste and the nutrition far more than you ever could in any other process to make spirulina. But you also have this neutral protein, which is an ultra-sustainable protein, neutral in taste and color. It's not green, it's a cream color, and makes a plant-based milk similar to an oat milk or an almond milk, etc. So we're collaborating with large dairy companies, for example, for that. And then you also have natural colors, and the large beverage companies are super interested in truly sustainable natural colors, blue colors, green colors, etc. And then you have even collaborations with pharma companies looking for biological drug delivery systems or for bioactive vitamins and minerals. One of the beauties is that microalgae are superfoods. every part of the microalgae has got some sort of value. And that also helps with the commercials, because literally sometimes some processes struggle because you extract a tiny amount of product and you're trying to commercialize that tiny amount of product. Here, every part of the microalgae has value in different applications. So absolutely, we're collaborating with quite a few wide range of different multinationals in different parts of the world for different reasons.
Very good. Now, you've talked publicly that BioSolar Leaf installations could sit next to other manufacturing facilities, so biogas and bioethanol, and presumably other big manufacturing plants as well, to use the CO2 that's generated in those processes. Have you got any of those industrial partnerships lined up? What's the plan for that in future?
The first plan is actually to use agricultural waste in the location that we've determined in Portugal. And so it's in the middle of like an olive plantation where the olives can't grow. And we would take the olive waste, burn that, generate the CO2, and then actually some of the byproducts are biostimulants to help the olives grow again. And that's simply because of location. But you're absolutely right. This could be located next to any industry that's emitting carbon dioxide. It might be a brewery, it might be a biogas production, it might be a fermentation process. And yeah, we're happy to collaborate with companies to build such facilities. We're building our first facility in the middle of Portugal with agricultural waste. But this, even though it's going to be making several hundred tons, it's effectively a very large model facility, because the partners we're talking to are talking about building facilities much, much larger. And we can then demonstrate with this facility that we're building that literally it can be built anywhere to any size in any region of the world. Yes, right next to an industry or in the middle of agricultural land.
And in terms of food regulations, I mean, the European Union is quite strict, I know, and they have their own restrictions on commercial use of quite a few microalgae species. Is that a massive regulatory constraint for you, particularly in Europe, and how do other jurisdictions look at these type of regulations?
This is another reason we started with spirulina. There is a handful of microalgae for which have been in common food usage around the world, and those are okay. And as long as you use natural mild extraction methods, there are very few regulatory hurdles. But you're right. I mean, the easier the regulation, the more microalgae you could potentially make with the same process. The process is agnostic to whether it's non-genetically modified or genetically modified. We've obviously focused on non-genetically modified organisms and food-approved organisms. But for pharma applications, etc., I mean, the microalgae doesn't care, and the industrial photosynthesis works with them. So yeah, regulation is not a blocker, but it's a slower downer. So you really could unleash all kinds of possibilities with less regulations with the same technology. Absolutely.
And why do you think those regulations exist? I mean, because presumably there's no danger to health, or are they just legacy rules that haven't been changed, or why have they not been lifted?
No, the regulation exists for good reason for any foodstuff, any new foodstuff that's made through any process. The regulation is there to just put checks and balances in place. That's all. So it quite rightly says, look, if it's been in common food usage around the world, and therefore efficacy has been proven, then that's fine. But no, it's quite understandable that you do need regulations in place to make sure that you don't have wayward scientists developing all kinds of things that they shouldn't be doing before we eat them. It's more about the bureaucracy around the regulation that would be the main concern. What you want is a nice, simple, streamlined, clear process to go, and low-cost process to get over the regulatory hurdles. I'm all for regulation. Just make it simple to actually to comply.
Yeah, I mean, with the savings that you could bring in terms of protein production, both from an environmental and cost perspective, it seems seems like it should be something that you guys are lobbying for to accelerate, really.
Yeah, absolutely. In our case, it's not a problem, like I said, but yeah, you could have all kinds of potential unlocked with in many other cases. The easier it is, but like I said, it's important to have checks and balances always. I mean, we're talking about food here, and or even cosmetic ingredients, etc. We're talking about things that you are going to consume. So yeah.
Now, the microalgae sector is quite nascent still, but has had a fairly long history of companies that have struggled to scale commercially for all sorts of different reasons. What do you think makes Arborea's approach fundamentally different from those previous attempts that have come before?
That's a good question. This is completely unique technology. So in the past, microalgae has been made through raceway ponds or through internal photobioreactors or fermentation. Each of them can be good, but they can also have limitations. In raceway ponds, you can have the possibility of cross-contamination from either organic toxins or heavy metal contamination. Internal photobioreactors can be extremely expensive. They have to be stacked vertically, and they're very hard to scale. Fermentation, similarly, may require compressed gases or expensive capex. Our process basically overcomes every one of those hurdles. It's low capex, it's eminently scalable, it's completely controllable. You have no possibility of cross-contamination, and you have excellent both taste and nutritional control. So, which is good for us in the sense that you quite rightly mentioned that microalgae have been studied for many, many years. There have been some excellent studies in medical journals, food journals about the potential of microalgae if only there was an enabling technology to make it in a controlled way, in a commercial way. And actually, we can ride off the back of a lot of excellent study and research that's been done over the years by saying, here is that enabling technology. So it's actually very good news for us.
Very good, very good. And in terms of the commercialization, so how's that going to roll out? You've obviously got Portugal coming live. I think you're looking at other regions like the Middle East. What's the plan for rolling out across the world?
So our first full-scale factory will be up and running in the middle of next year, and we've got offtake agreements for most of the capacity of that, and we've got joint development agreements, in fact. So we're considering now to expand that even further than we'd anticipated. Then, yes, we were in discussions with companies as far away as Middle East and the US. The reason for building such facilities is different in different regions of the world. In Asia and in the Middle East, it's about food security, often because the lack of fertile land to feed the population. In Europe, it's often about both food security and sustainability, the fact that you want a food production process that doesn't involve deforestation or loss of biodiversity. In the US and North America, it's about a food system that can give you controlled production without risk of cross-contamination for health and nutrition, for healthy longevity. So it's the same technology, different reasons for why companies that we're collaborating with are interested in different regions of the world. And what we'll be doing is either joint venture or partnerships or licensing of technology in a lot of these regions. We're not going to do it all by ourselves. I mean, we're building this first full-scale factory, but going forward, this will be through joint venture and licensing.
So in terms of your investors, you're fully funded. Are you looking for new investment to help with that rollout anytime soon?
No, we're just closing our latest investment round, and this will take us through to profitability. Obviously, depending on our plans after the first factory has been built and we're producing, then we might be looking for different types of funding. If we are going to build a much larger facility, either as a joint venture, for example, then we would. We haven't decided. We haven't decided yet. I mean, we want to do things in logical stages. The first thing is to we have the pilot facility up and running. We want a full-scale factory up and running. We want to prove to the world all the techno-economics. They're very, very attractive techno-economics, but we want to prove that. And at that point, depending on who we're partnering with, that will probably determine to what extent we look for further funding and for much larger facilities going forward.
And have any of your customer base also invested as strategic investors, or is it who are the investors in the business?
So the investors in the business are mainly venture capital and European grant money that's gone into the funding. The customer base are basically associated with us in the form of offtake agreements and paid joint development agreements. We've deliberately shied away from, at this stage, corporate venture capital, because that can sometimes limit who you can talk to in terms of customers. But going forward, that might be something that we consider depending on which segments we are expanding into.
Very good. That's great. Thank you very much, Dr. Kaly Chatakondu, who's Global Commercial Director at Arborea. Now, if you'd like to find out more about the company and the BioSolar Leaf technology, you can visit arborea.io. And for more interviews, analysis and briefings on the climate economy and technologies, please go to climatesolutions.news. If you found the conversation useful, please do share it and subscribe wherever you get your podcasts, and we'll be back shortly with more interviews from the people shaping the global response to the climate challenge. Thank you very much.
Thank you.